Good evening, ma'am.
Good evening.
Very good evening.
Good evening, ma'am.
Good evening.
Like, can you give a brief what we did yesterday?
Yeah, sure. Let all of them join first. We'll take it.
Okay.
Only 3 students are there.
Ma'am, did you discuss about theta yesterday?
About
Theta.
theta. Okay, where you got to know is this theta?
Good evening, ma'am.
Good evening.
Like, like today, nah, just today when after I came to school, I just wanted to check what we had done yesterday. So, when I went to IJAP and I saw the screenshot, there was one PDF. When I opened it, I saw that we're talking about theta.
Then you must have looked up on the heading also. What was the heading?
Uh, Ma'am, multiple reflections was the heading.
Okay. And except theta formula was also mentioned. What was that?
Yeah, like you gave one formula like n equals to 360 degrees by theta minus 1.
Hmm. So when we place two mirrors at certain angle, then n number of images we find, because in those two mirror, image of image is also getting obtained. Image of image. So
Yes, ma'am. Like I tried that experiment at home. Like I kept two mirrors and the image was like parallel.
hmm,
So, ma'am, like how we will find the value of theta here? Like,
that you should be having if you are keeping the two mirrors.
ma'am, I didn't understood.
Here, if you are experimenting, you should know at what angle, or you can just simply draw two lines with using protector, with using the D, okay, and draw two lines and then place the two mirror.
Okay, ma'am.
Okay, now I think let's begin. Most of us are doing it. Fine. Everyone, please put on your cameras. Don't wait for me to ask you the same thing again and again. Now, first, we are going to see that how number of multiple reflection takes place. Then we'll move to convex mirror. Hold on. Yeah. Is that visible? PDF?
Yes, ma'am.
Yes, ma'am.
Please excuse me for this, that I am not able to draw perfect straight line. Some issues will also be there with the pen tab also. Not a perfectly. Please, you draw it. Okay. So I'm placing two mirrors here at 90-degree angle. Let's see. Now, I gave you a line that is incident on this one of the mirror. This is mirror one. This is mirror two. On second mirror, the light is incident on the second mirror at angle 45 degree, let's say. Okay. So the angle 45 degree if I am giving, that is with the normal, because incident angle is always measured with the normal. Is that fine? Now, how will you complete this light ray? After reflection from the mirror second, if incident angle is 45 degree, the reflection angle should also be 45 degree. And after making reflection angle of 45 degree, it should travel straight as much as it can until it did not find any of the path to, reflect back or some hindrance. Now it finds another path. It is this. Okay. Let's suppose now this is the second point of incidence, and let's draw the normal here. The another normal. This is N1. This is N2. N1 and N2. Now, can you find it? What angle of incidence would be obtained here the second time?
Ma'am, 45 degrees.
How?
Because with N2 it is forming 45 degree.
Hmm. I'm asking when it strikes the second time. This is not an incident angle, na? This is a reflection for the first incoming ray. Now, at what angle will it be incident on the second time? By chance, your answer is correct. It will be 45 degree also. So you can just use, laws of triangle here. If you see the two mirrors are kept perpendicular to each other, you can say if this is 45, the remaining angle should be 45. 90-degree normal. Half is
Yes.
45, the remaining should be 45 or not?
Yes, ma'am.
Yes, ma'am.
Okay. Now in this triangle, look at the pencil. One is 90, one is 45. Then this remaining should be
45.
why? Because angle sum property. Do you know that
Yes,
the
ma'am.
sum of angles of a triangle is always 90? Accordingly, this should be 45. Now, by this 45, this is normal, and whole 90 minus 45 is again 45. This was a longer way, I know, but you can simply look from this triangle also, that is obtained with two, pink lines and one blue line. Two normals are inclined at 90 degree because those normals are drawn on two perpendicular lines only. So this triangle also, 90, 45, so third should also be 45. Very simple. Now this reflection angle will also be again 45. I took
So like
the example because 45, 45 finding is very easy. Now I'm giving you this. Another question for you is, this time the light strikes here at an angle of 30 degree. Find the reflection on the second mirror. This is our first mirror. This is our second mirror. Now find a reflection on the second mirror. Angle of reflection on the second mirror. Please find it. Draw it in your notebooks.
Ma'am, it is like we should use the formula, right?
Pardon?
Ma'am, we should use the formula, right?
No formula is used here, just simple law. Draw the lines, use, draw the normal and then angle properties, triangle properties, etc. You need to draw it, then you will find.
Ma'am,
Hmm.
I am I got confused.
Why?
I'm not getting why are you what kind of like not getting why are you drawing the diagram uh, I didn't understand from the starting of the question.
Sometimes the question arises, and this is not because, if it is not mentioned in your NCRT, then we should not do it. Is it the rule?
No, I'm asking I didn't got the question from the starting.
We should know that at what angle. We should be familiar with the angle of incident reflection, how these are, made as per with the normal, and number of images we should also be able to find out. So such is a type of knowledge, you can say. Now, if this is 30, another ray that will be reflected here will be 30-degree angle. Now at this point, another normal is here. N12, I'm giving it name because both normals are here. Now again, as I told you, both normals are drawn upon the two perpendicular lines. So if you see, this is forming a square. If this is 90-degree, let's suppose I join these two normal, okay? 90-degree plus 30-degree, then this angle is, will it be
60
60 or not?
degrees.
60. So second incident angle is 60. So it means the answer to our question is that another next angle of reflection from second mirror will be 60-degree.
Ma'am, how do we know that it's 60?
Hmm?
Ma'am, how do we know that it is 60?
Dear, I'm telling you, I'm explaining now. Look, if when our two mirrors are kept at 90-degree angle, then normal to those normals are 90-degree line, then it means this part is forming a square, isn't it? Look at the figure carefully. Is it clear now?
Yes, ma'am.
Simple. Please draw it. Draw the two diagrams.
Ma'am, the first angle is 30, right?
First answer is 45.
No, no. The second diagram, the
Hmm?
first angle here
30,
mentioned is 30.
30, yeah.
So, ma'am,
Hmm.
so the angles and property of triangle is used in, or it is used in this kind of questions everywhere. Like it is always, does it always form a triangle with 90 degrees?
See, if I do not align my two mirrors at 90-degree, obviously I know that it's gonna quite complex. So at this level, at the grade 7 level, if the question will ask to you, they will give the two mirrors at 90-degree only, because in other cases, then more complexity will enter. So at least you should know the basic. That's why I'm telling you this. Got it? Fine. Is it okay?
Yes, ma'am.
Hmm. I hope all have drawn this. Now let's move to the second spherical mirror. Hmm. Can anyone tell me what type of mirror are convex mirror? Means if we touch them, how do we feel?
Ma'am,
Hmm?
they're curved outwards.
Very good. They are curved outwards, as shown.
And also they're diverging mirrors.
Diverging mirror, very good. We'll learn why they are known as diverging mirror.
Ma'am, what is the meaning of diverging?
Just telling, please have patience, throw a little patience. So when we touch the convex mirror, their mirror surface is bulged outwards, bulged out, and the inside curved surface is concave. Okay. So that side is painted. We have to just notice that mirror wala side. Okay. Now, like in case of concave mirror, convex mirror also has a property that when we point it towards the sun's rays or any rays that are coming from infinite distance, from far off distance, yani means parallel rays, okay, because that are considered parallel. When parallel rays strike, that all the rays will diverge, means something which spreads out in direction, open direction. They are not going to converge at all. They are going in diverse way, moving apart from each other. Okay, they diverge. But what has been noticed, that if the observer is standing here, suppose the sun is here, okay, you are standing here facing the mirror like this, and you are looking into the mirror, then you find that sun's bright spot image is formed in behind the mirror only. Like in the plane mirror, you find the image in the mirror only. In that mirror, you will see a very clear spot obtained in the mirror, and that will be the image of sun or any other object from which light rays are striking the mirror. Is that okay? And because sun is at infinite distance from us, and that is, lakhs of kilometer away, but the image we see is appearing like it is just 1 meter away. Now, this is the case, bit contradictory with the plane mirror. Plane mirror reflects the image which lies at the same distance as we are standing from that. But this is not the case with convex mirror. It shows the image quite closer to the mirror. Did you note the difference? Did you note the
Ma'am,
difference?
in a convex mirror, the light source can only be from infinite distance, right? Because there is nothing like focus or center in a convex mirror.
I am going to tell you that. Please keep patience. I'm coming to that point.
Okay, ma'am.
Every parameter is there in this mirror also.
Okay, ma'am.
Now, the point where you will find the image of sun, and which is already, quite closer to the mirror, that point, because the rays are actually, look at my pen, the rays are, let me use another color, wait, pink. Light rays are not actually meeting, they are diverging. This movement is known as diversion. These directions, spreading apart away from each other, this diverging nature. So how we can see the image? Because if we produce back those diverging rays back, although this is not possible practically, can you go into the mirror and draw such lines and make the rays meet? No, you are not doing that. The mirror is only doing that. And when you touch it from the back side, it is just a surface curved inwards. So how much is this distance? It means anything happening in this area is said to be virtual, apparent. Got it now?
Yes, ma'am.
Did you get it now? Why such type of images are known as virtual? Because the mirror is not a sphere in which we can say that inside the image is obtaining. The image, when we touch it, it is curved inwards already, no more distance, but still, looking into the mirror, the image is visible. That's why this image is known as virtual. And the point where all the diverging rays are meeting backside behind the mirror, they are converging at a point which is known as the focus. This is the principal focus. So here you are introduced with the focus point. Is it fine?
Yes, ma'am.
Note this down, then I'll move ahead. Noted?
No, ma'am.
No, ma'am.
Be quick, children, please. Okay, should I raise it off?
Ma'am, since it is being uploaded in the app, we don't need to note it down, right?
I mean, this diagram at least you can note now because I have to erase this.
Okay, ma'am.
Because via diagram, when we understand, so whatever I'm speaking, I'm trying to, either draw or write something mixed up form. So everything cannot be mentioned in the notes. So that's why you should at least draw a diagram or something that I'm writing apart from the notes. Notes are, I upload, I know. Done now?
Ma'am, 1 second.
Moving ahead. Now come to the parameters. Again, all the spherical mirrors are a part of a sphere, although that sphere is imaginary. So let's complete this sphere. Please excuse me because I'm not able to draw the perfect sphere and perfect shapes on using the pen tablet. Okay, let's complete a sphere out of which this piece of mirror has been carved out, convex mirror. Now, like every sphere has a center, this should also has a center point. Okay, let's say this is a center point. C denoted by capital C, center of curvature. And like, similar to the concave mirror, this focus point lies between the pole and center of curvature. This point is known as the pole, that is the middle point of the aperture of mirror. You remember what is the aperture? Why? What does this word mean? What does this word mean?
Ma'am, my battery went down, so I had to leave and join. What did we do?
Why don't you connect your charger?
Yes, ma'am, I connected and I rejoined. What did we do?
Okay. Stay focused.
Is it like a space like thing which
Space
like
or
the
the
light
region, the
passes?
overall region of the mirror is its aperture. The center or the middle point of that aperture is pole. If we join the pole and center of curvature, this horizontal axis is known as principal axis. This is again with similar to the concave mirror. Principal axis. Now, in between pole and center of curvature lies a principal focus. And as I told you, uh, any distance will be measured with the pole, okay? Till focus, it is focal length, already marked. And till center of curvature, it is a radius. Radius is same like in every sphere, every circle. From center to circumference is a radius. Here also it is radius. All see, no need to remember this thing, focus and radius of curvature, that's fine. You just need to remember one thing, that pole, focus lies between pole and center of curvature, and this is the rough diagram. Is it fine? So why convex mirror is known as a diverging mirror? Because yeah, after reflection from the convex mirror, the parallel rays of light spread. Since a convex mirror diverges a beam of parallel light rays, therefore it is also known as diverging mirror. I hope it is clear now.
Okay.
When you will look at the concave mirror back, you will find that after striking the concave mirror, all the light rays actually met at a point known as principal focus. Here, these are not meeting, they are spreading apart. And that's why we have they all automatically gets produced back and meet at a point such that the rays are coming out from the focus only. So everything is happening virtually. This is not real. That's why the image obtained behind the mirror, which we see in the mirror, is known as a virtual image. And obviously, I hope you all can imagine the size of sun, okay? And on that, such a small piece of mirror is, obtaining this such a small image of like 1 millimeter size, hardly 1 millimeter. So you know how much difference between the size of images as well. So whenever you need to have a wider view with a small images, means zoom in image doesn't matter for you. You just need a wider image. Like suppose, yeah, on the vehicles, in the car, two-wheelers, etc. When we want to have a wider view of our backside, how many number of vehicles are passing by. So there we use this convex mirror. They have a greater use as a rear view mirror. Got it?
Ma'am, also some traffic mirrors.
Yeah. See, mainly these are used at public places, at the corners of metro station, parking lots, shopping malls, railway station, any public place you will find such mirror very easily. Because we don't want to see the image, zoom in image of any vehicle. We just want to see how much, distance should be kept to in order to keep my vehicle safe, and how to take a turn, safety and security purpose. So basically, they gives a wider view with a smaller size images. Note down this line. Convex mirror gives a wider view. Please write down with small size images. And that's why they are used as a rear view mirror in vehicles or in public places. Parking areas, shopping malls, railway station, metro station, etc. Please note down all these uses.
Ma'am, can you repeat the second point, like smaller size image? Then what you wrote?
That's why they are used as rear view mirrors.
Okay.
Ma'am, like after a smaller size image, what is that?
That's why they are used as rear view mirror.
Ma'am,
Hmm?
convex mirror, the whatever image we want to look.
Written, should I clear the page?
Yes, ma'am.
Everyone, please respond.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Cut.
In a convex mirror, whatever image we want to see appears in a wider view, right?
So one of the main point about the convex mirror is that image formed by a convex mirror is always virtual, erect, and smaller than the object, or you can say diminished. If you remember in concave mirror, I told you basically I categorize the image nature in two ways, means from infinity till the point of focus, the image form is real and inverted, and size is sometimes smaller, sometimes bigger. But when you keep the object in between pole to focus, then the image is virtual and erect. Okay. Whereas in case of convex mirror, doesn't matter where you are keeping the object, because object will be kept on the left side. Just remember that image form will always be virtual, erect on same side, and smaller. Please mute your mic. Background is
Your voice is low.
background noise creating a disturbance. Mute your mic. Please note down this, that convex mirror always forms virtual, erect, and smaller in
मम्मा
size.
ମତେ ନାଇଁ ଲାଗୁଛି ଆଜି ଥରେ ପଢିଥିଲୁ
Children, please mute your mic. Study class.
ବହୁତ ପଢିଥିଲୁ Mom, convex mirror forms what?
Pardon?
You said convex mirror forms.
Convex mirror forms virtual, erect, and smaller sized images. You write the complete word virtual, E for erect, and smaller sized images. And this is why they are used as a rear view mirror. See,
Mom, can you repeat the point?
convex mirror forms virtual, erect, and smaller sized images. Hmm.
Here, it is said that in a convex mirror, the image is always in a smaller size, right?
Hmm.
But you said it gives a wider view.
I cannot hear you anymore.
Ma'am, you can hear me now?
Yeah, yeah.
So, like, the point says that in a convex mirror, the image is always going to be smaller size, right?
Hmm.
So, like, but you said it is in a wider view. So, like,
Yeah, see. Did you notice that the light rays after striking the mirror, they are diverging, they are spreading apart. Okay. So every object that is present here in this area, all these images will be confined to this small area. So you have a wider view in a smaller mirror. Wider view, I'm telling, of your backside. That is gonna trap in this small mirror. Images are already smaller in size, that's why it is able to cover a larger view, because these diverged rays are only getting virtually like virtually meeting on the back side of mirror.
okay, ma'am.
So don't focus on drawing these two diagrams, not drawing of diagram. This is just to explain that how they always form smaller image and cover a wider view. Okay, so use of convex mirror is to see the traffic at the rear side or back side on the road. These are used in vehicle, cars, scooter, buses, etc. And yes, na, like in the public areas, why they are installed as a security mirror, shop security mirror to keep an eye on customers. Because one cannot look so many customers at 180-degree angle. But if we fix up a small convex mirror at the corner, only looking at the mirror will tell me which person is doing what. Is it fine? Now got it?
Ma'am, there's some noise coming from somewhere. I think someone is on mute. Ma'am, now it's stopped.
Okay. That was the sound of my AC, sorry. Okay, I'm erasing it off. Rear view mirror for vehicle and shop security mirror. I hope by looking at the images.
Ma'am,
Hmm,
can you just scroll up like I was half done with the diagram, like the second diagram.
Here I'm telling you 7th class. Okay, I'll upload the PDF, by removing these diagrams. I'm telling you, don't draw these. These are of no use to us. It is, I have just included here so as to explain you. No need to draw these two diagrams. Only the upper one, top one is sufficient.
Okay, ma'am.
So this and this are giving a proper idea of the use of convex mirror. Fine. Nothing much, but yes, in the next class, we will discuss a bit about lenses because lenses are not so in detail in your book. So this will be continued in the next class. Fine.
Yeah, okay, ma'am.
Let's recapitulate quickly. Hamza, uh, why convex mirror is also known as divergent mirror?
Ma'am, because it diverges from the what is it? Ma'am, like when the light comes on the convex mirror, the light diverges back.
Okay. Kshitij, what is the nature of image obtained by convex mirror?
That it is virtual, it is erect, and it's also small.
Okay. Sriyansh, state the biggest use of convex mirror and why it is used. Diyansh? Rishit? Okay, Sriyansh, but please do answer in chat. Yes, Rishit?
Ma'am, are they used in like vehicles mirrors?
Why?
Ma'am,
Why?
and because to check the vehicles at the back. Right?
Okay, great. So please prepare for your exam well, covering the syllabus of plane mirror and concave mirror. And fine. By the next class, this chapter will probably will get over. Okay. Fine. Bye bye. Good evening.
Bye.
Bye, ma'am.
Thank you, ma'am. Bye, ma'am.
Thank you, ma'am. Bye, ma'am. Bye, ma'am.